Welcome to The Explainer. Today, we're going to metaphorically tear down a drone. We're going to look inside and figure out what makes these things tick, what allows them to pull off their incredible aerial ballet with such, well, breathtaking precision. Let's dive in. You've seen it, right? A drone just hovering, almost frozen in midair, like it's completely ignoring wind and gravity. I mean, it seems like magic, but it's not. It's pure technology. A super fast conversation happening between a whole team of sophisticated parts, all working together like a perfectly tuned orchestra. So at the very center of this whole technological marvel is the command center, the flight control system. You've got to think of this as the drone's brain. It's where every single decision, every tiny correction happens faster than you can even blink. And right at the heart of this brain, you have the main controller. This thing is basically the central processing unit, and it is a beast. It's constantly sifting through this massive stream of data, from your commands as the pilot, all the way to the input from its many sensors. Its one and only job? To translate all of that information into the precise commands that keep the drone flying perfectly. Okay, but a brain is pretty useless if it's just flying blind, you know? To make smart decisions, it's got to be able to perceive its surroundings. It needs senses. So how in the world does a drone see, feel, and navigate through its three-dimensional world? This is where it gets really, really cool. Modern drones are just packed with a whole suite of sensors that act as their eyes and ears. These things provide the main controller with a continuous, real-time stream of data about its position, its orientation, and everything going on around it. All right, first up, the most basic sense of all, location. A drone needs to know, where am I on this big blue marble? For that, it relies on its GNSS receiver. By listening to signals from a whole constellation of satellites way up in space, it can pinpoint its exact latitude, longitude, and altitude. This is the drone's global positioning sense. Now, the secret to a drone's perfect balance is the IMU, which is a lot like our own inner ear. Seriously, it's got a gyro sensor to detect any tilt or rotation, and an accelerometer to sense changes in speed and direction. Together, they are constantly sending updates to the brain. Hey, we're tilting a little bit left. Whoa, now we're accelerating forward. And that's what enables thousands of micro-corrections every single second to keep it flawlessly stable. So knowing where you are is one thing, but knowing which way you're facing, that's a whole other problem. And that's the job of the geomagnetic sensor. It's a digital compass, pure and simple. By sensing the Earth's magnetic field, it tells the controller exactly which way the nose of the drone is pointed. And finally, a drone absolutely has to know its altitude. How high is it off the ground? Well, altitude sensors use some pretty clever tricks, like measuring tiny changes in air pressure with barometric sensors, or even bouncing lasers off the ground to figure out its height with pinpoint accuracy. So the brain has processed all the commands, and it's used its senses to understand its place in the world. What's next? It needs to translate all of that data into actual physical movement. So it's time to introduce the drone's muscles. And this whole chain of events happens almost instantly. From the moment you move the stick on your transmitter to the second the drone actually moves, this entire sequence is a seamless flow of information, from your brain to the drone's brain and then right out to its muscles. Now, a key player in this whole chain is the ESC, or Electronic Speed Controller. You see, the main controller communicates in digital signals, but the motors need raw power to spin. The ESC acts as the interpreter, translating the brain's super precise instructions into the exact amount of power each motor needs to spin at any given moment. Have you ever noticed that a quadcopter's propellers spin in opposite directions? It's a brilliantly simple solution to a really complex physics problem. Each motor creates a rotational force, it's called torque, that would otherwise cause the drone's body to just spin uncontrollably. By having half the propellers spin clockwise and the other half counterclockwise, these forces perfectly cancel each other out, making sure the drone stays stable and flies straight. It's genius. Of course, a brain, senses, and muscles, they're nothing without energy. They need a power source to bring them to life. And that brings us, finally, to the beating heart of the drone, the battery. Now, this table highlights the key stats for a drone's battery, but here's the really critical takeaway. It's all a delicate balancing act. As a flight goes on, the battery's voltage naturally decreases. So, to compensate and maintain consistent power, the ESCs have to draw more current. This little dance is precisely why flight times are limited, and why really understanding your battery is so essential for a successful and safe flight. So let's put it all together. A drone's seemingly effortless flight isn't the result of just one single component. No way. It's the result of incredible, high-speed teamwork. It really is a symphony of flight.
This is the magic. The brain is constantly listening to the senses, and in response, it's constantly telling the muscles to make these tiny, imperceptible adjustments, all powered by the heart. This continuous feedback loop of sensing, thinking, and acting is what creates that incredible illusion of a machine just hanging perfectly still in the sky.
And it is this intricate, coordinated system that is unlocking the future. From automated package delivery to breathtaking cinematography, the symphony of flight inside every single drone is fundamentally changing our world. And it raises a fascinating question. What's the next great performance these machines are going to enable?